Good morning, good afternoon, good evening, wherever you are in the world. Thank you so much for joining us today. My name is Joy Vastaros, and I'm going to be your webinar host for the day, coming to you from Houston, Texas, in the United States. I'd like to welcome you to today's Siemens Global webinar. Our topic is how to change and thrive in the global industrial machinery business. And I'd like to welcome today's speaker. We have David Chadwick with us today. David Chadwick is the Business Development Manager for the Solid Edge portfolio. He is focused on industry solutions from the Solid Edge portfolio and has 30 years of application engineering, project management, and marketing experience, and has been responsible for many successful product data management implementations in small and medium-sized manufacturing organizations globally.
Thank you, Joy, and it's good to talk with you all today. Here is the agenda that we will follow in the next 30 minutes or so. We'll first look at the impact of digitalization on industrial machinery and equipment manufacturers. We'll look at some of the key trends that we see impacting these manufacturers, including increased demand for customized solutions, increased electrical content, and compliance with customer requirements and industry regulations. And we'll also look at some of the solutions that we propose to address each of these trends. And then finally, we'll look at some case studies of some of our customers who are meeting these trends. And then we'll have a final Q&A session. One of the themes of our presentation today will be that of increasing complexity. We see that manufacturers are faced with increasingly complex requirements from their customers. Some of the issues that we see that are driving this increased complexity include the need to connect products to the internet, the need to meet environmental regulations, and the need for machinery and equipment manufacturers to have the flexibility to create customized products that meet end user demands. So with all this complexity, how can manufacturers make decisions about their products with confidence? How can they drive innovation in today's highly competitive market? We believe there are three key components that provide a significant competitive advantage for our customers. We provide engineering solutions that deliver a comprehensive digital twin. We make solutions and services personalized and adaptable. And we provide a flexible, open ecosystem that works flexibly with your existing systems and data. We see that digitalization changes all areas of life. The way we stay informed, the way we travel, the way we buy things, and the way we design and manufacture products. It is also changing business models. The pace of innovation and the ability to disrupt are becoming key success factors in product development. This increases the pressure on manufacturers and opens up new business opportunities at the same time. Our focus today is on manufacturing, and here we see the impact of digitalization in many different areas. For example, in the area of design and engineering, we see new technologies such as generative design, integrated fluid flow analysis, virtual and augmented reality, and the increasing use of mobile devices for engineering applications as having a big impact. And in the manufacturing area, we see trends such as the smart factory, where products that are going through the manufacturing process report on their status, and the equipment used to manufacture the products also reports on their maintenance and quality issues. And we also see increasing deployment of new manufacturing processes involving, for example, additive manufacturing. And these new technologies are also being deployed for testing and installation. This is sometimes referred to as virtual commissioning, and enables manufacturers to validate product performance before shipping the product to the customer. Today, our focus is more on the industrial machinery and equipment manufacturing sector. But as you can see here with this list of some of the industry segments where we have customers, this is a very diverse sector. And the material we discussed today also applies to other manufacturing sectors, such as consumer durables manufacturers, aerospace and automotive supply chain companies, and manufacturers of medical devices. But irrespective of the type of products you design and manufacture, we see that digitalization is absolutely essential because products are becoming more complex, multifunctional, and incredibly sophisticated. In this example, the modern sewing machine that you see on the right now includes a touchscreen interface, sensors to detect material location, and it is connected to the internet to download patterns and report on maintenance issues. Products have changed and the market has changed, your customers have changed. The question we would ask you is, have your engineering processes evolved to meet these changes? A key part of the solution proposed by Siemens is to create a digital twin of your product. This is a detailed 3D digital model of your proposed product. The digital twin can be used as a basis for all areas of product development, including, for example, managing customer requirements, concept and detailed design, simulation, manufacturing, installation, and service. We will discuss how the digital twin helps manufacturers address the challenges they face to bring new products to market quickly and efficiently. At this point, we'd also like to introduce you to Solid Edge, a portfolio of affordable, easy-to-use software tools that address all aspects of the product development process. Solid Edge combines the speed and simplicity of direct modeling with the flexibility and control of parametric design, and all made possible with synchronous technology. Solid Edge enables you to implement the digital twin concept that we saw on the previous slide, enabling digital transformation for startups, small and medium-sized manufacturers, and departments of large enterprises. And Solid Edge is a cross-industry solution that is used in many different manufacturing sectors. Now we'll look at these three key trends that we see impacting manufacturers and propose some solutions. The first trend is end-user demand for customized products, resulting in demand for more highly customized machinery. The second trend is increasing electrical content to meet customer demands for more customized and connected machinery. And the third trend is increasing pressure to track fulfillment of customer requirements and their ability to prove compliance with industry regulations. The impact of these three trends together that we see is increasing complexity of machinery and equipment and increasing complexity of your product development processes. So what is the impact of this increase in product complexity on the manufacturers of these products? This research from industry analyst Technofa showed that increasing product complexity can slow the product development process and can result in delayed time to market, lost revenue, project budget overruns, and poor product quality. We will now look at the trends that are driving increased product complexity and their solutions in more detail. So the first of these three trends is end-user demand for customized products that in turn is resulting in demand for more highly customized machinery. Again, here is some more research from industry analyst Technofa. This research focused on how top performers in the area of manufacturing differentiate themselves from their competition. The research showed that they do this by being faster to provide quotes for their customers, and then by also being faster to deliver the final product to these customers. These manufacturers also have the capability to include higher levels of customization in their products. So let's look at the challenges, how we can help, and the benefits that we see manufacturers are achieving in this area. Well, the key challenge we see is for manufacturers to be able to efficiently engineer products that meet customer specifications while meeting delivery schedules. We can help in this area by helping you to configure products based on family of parts and family of assemblies defined in 3D CAD. If you like, this is the basic entry point in this area. Then we also have more sophisticated solutions. For example, being able to manage options, variants, product configurations, and product costing using an integrated PLM solution. And then we also have solutions that enable you to automate new product designs using advanced E2O, which is engineering to order processes, and automation technology in this area. The benefits that we see manufacturers can achieve, including reusing proven components in new design projects. This enables them to reduce their risks and speed response to customer RFQs, and also improved order engineering lead times, throughput, and costs. Let's talk a little bit more about, firstly, C2O, or configure to order type processes. So with C2O, or configure to order processes, the primary design challenge for manufacturers is selecting the right product based on the customer specified options, where all of the parts have already been designed, or at least defined as families of similar parts and assemblies. The enabling solutions that we have in this area are based within our 3D CAD solution. And these include the ability to create family of parts and family of assemblies within the CAD environment. These are typically driven by Excel spreadsheets or variable tables. Specifically with our Solid Edge 3D CAD solution, we refer to these as Solid Edge family of parts and Solid Edge family of assemblies. The next level up is using a PLM solution, in our case, Teamcenter Product Configurator, to actually enable you to drive product configuration, also options and variants, and even product costing as well. So that was the C2O, or configure to order area. The next area of complexity is engineer to order. So with E2O, or engineer to order, the primary design challenge is rapidly designing new parts and assemblies to meet unique customer specifications based on your own engineering and manufacturing capabilities. Here we have a solution called RuleStream, which applies standards-based engineering to enable you to support custom manufacturing. The second area that we'll look at in terms of trends that we see impacting manufacturers is increasing electrical content that is required to meet customer demands for more intelligent and connected products. Here are some results of a recent survey of design teams that was run by engineering.com. The survey asked about the value attributed to electrical and electronic systems in current design projects. The majority of the survey respondents, actually 71% of the respondents, all design engineers, said that the value attributable to electrical systems in their products is increasing, and fully 37% said that the value attributable to electronic systems is increasing significantly. We forecast that this trend will continue to grow. Let's look at an example of increasing product complexity related to increasing electrical content. Here on the right-hand side, we see the wiring harness for the Chevy Bolt electric vehicle. You can see the wiring harness here is already fairly complex. On this slide, we see the wiring harness for the Chevy Bolt electric vehicle with the advanced driver assist systems. So these are systems, for example, including automatic braking, automatic parking, These type of systems require more cameras and sensors, and you can see the huge increase in the complexity of the wiring harness for these additions to the capabilities of the vehicle. Let's look at another example. In this case, one of our own customers, a manufacturer called Thermaplan, who manufacture coffee machines for commercial establishments. Even in this relatively small piece of equipment, you can see that the wiring harness is fairly complex. In this case, Thermaplan is using Solid Edge from Siemens for 3D mechanical design, but they were actually using a fairly basic electrical design software package, which had really no intelligence built into it. By adding Solid Edge wiring design, they've been able to create intelligent wiring diagrams that enable them to run qualitative and quantitative analysis on their electrical circuits and integrate them into their mechanical designs. I think you can also see with the small size of this piece of equipment, routing these wires within the confines of this equipment is a very important task for them to do as well. So mechanical and electrical engineers need to work together more effectively throughout the product development process. And this is true if they are in different locations, in the same office, or sometimes in the case of small manufacturing companies and startup manufacturers, they may even be the same person. The recent Engineering.com survey also looked at the areas where project teams are losing time due to electromechanical design issues. For example, lack of communication between electrical and mechanical design teams was one of these areas identified, and the need for repeated testing and prototyping was another impact of this increasing complexity of electrical components in otherwise mechanical products. So for products that include an increasing number of electrical components, designers need to be able to answer questions like, do the signal wires have enough strength for the receiving component? Are the wire diameters sized properly to carry the current? And are the fuses the proper size? And in the area of electromechanical design, they need to look at issues like, are wires rubbing on any mechanical components? Are the wires running in hot areas of the assembly? And even, is there enough room for the wire harness around the mechanical assembly? So a possibility for addressing the trend of increasing electrical complexity in manufactured products is to implement software tools that have been developed to enable electrical and mechanical engineers to work together. These tools exchange data interactively between the mechanical and electrical environments and make it easy for engineers to see and react to changes made in the different disciplines. In this example, the electrical engineer determines that two electrical components need to be connected by a wire. The mechanical engineer receives the information about this connectivity requirement and routes the wire in the 3D mechanical assembly model. This determines the physical length of the wire. And this information is fed back to the electrical engineer, who can now accurately simulate the current drop in the wire and ensure that the optimum wire size is used. The third area we will examine is increasing pressure to track fulfillment of customer requirements and also proving compliance with industry regulations. In this area, we see that the complexity of customer requirements is continually increasing, and also that the cost of non-compliance with customer requirements and industry regulations can be very high. Let's look at a couple of examples of where product requirements were not tracked and met. This first one is the Samsung 7 notebook, which had a major issue with overheating and even causing fires. The problem was that the battery was expanding within too tight confines, and the negative electrode became bent around the positive electrode. In turn, this caused it a short circuit and overheating and fires. The impact for this manufacturer was the recall of 2.5 million Galaxy Note 7s and a total cost to the manufacturer of around $5 billion. The requirements, which was not met by this product, was that the design should allow for normal expansion and contraction of the battery that occurs with normal charge and discharge cycles. So somehow in the design process, this basic or very fundamental requirements was not logged and not tracked through the product development process. Another example is with General Motors, and this centers around a faulty ignition switch. The ignition switch could actually shut off while the engine was working and the vehicle was in motion. And one side effect of this was it could prevent airbags from inflating. The impact of this was a recall of 29 million vehicles. The requirement here, which was not accurately tracked and met by the design, was that the ignition switch should meet two very specific requirements: minimum torque required to change modes and the impact of vibration on the switch. One question we will ask you today is, how do you manage customer requirements for the products you design and manufacture? Most of the manufacturers we speak to are using office applications like Word, Excel, and emails to manage their requirements. This means that requirements are not linked precisely to design projects, and that requirements are not easily visible and retrievable by the engineers who are responsible for implementing them. And in addition to managing customer requirements, it is also essential to be able to prove compliance with pertinent regulations. This has a big impact on how you manage and document your design and manufacturing processes. And software solutions are available that enable requirements, both customer and regulatory requirements, to be documented, linked to product designs, and tracked throughout the product development process. And we see that implementing a solution for requirements management can result in the following benefits for designers and project managers. Firstly, the requirements are captured and managed in a consistent and repeatable way. Designers can more easily assess the impact of proposed design and requirements changes. An overall project process can be tracked and reported on as requirements are implemented and approved. And project managers can reuse requirements on new but similar projects. In this area, we have a specific solution called Solid Edge Requirements Management. Here, users can work directly with their CAD data while simultaneously managing requirements. We actually link requirements directly to CAD files and make these requirements easily visible to designers. They're able to track the fulfillment of requirements and report easily on the status of requirements for project managers. Throughout this whole process, an audit trail is maintained for all actions performed on a specific requirement. And here is a quote from one of our customers, one of our early adopters of this technology, Scott Vertel from Aero R&D. They had this same issue where collating product requirements from many different sources was very difficult for them. But they could see that using Solid Edge Requirements Management, they could have a tool to collect all those requirements in a consistent way, and that they could do this from right within their design software. At this point, let's cover 3 case studies of manufacturers who have implemented Solid Edge to improve their product development process. The first of these is a company called Control Microsystems here in the USA. They're a manufacturer of industrial laser-based systems. Some of the business challenges faced by Control Microsystems were to fulfill very specific customer requirements with very custom solutions. and in general, developing innovative applications of laser technology. Some of their keys to success have been implementing Solid Edge for fast completion of new design projects and also modifications of existing designs. And they are one example of a manufacturer who has created a digital twin of the products that they design and manufacture, and they use this digital twin throughout the company. Some of the results that they have achieved and reported to us include an excellent return on their investment in 3D CAD software. They've been able to complete design reviews in hours instead of weeks. They've been able to secure new contract wins and overall expediting customer review and approval of these custom machines that they design and manufacture. Another case study is from this company, Technofa in Italy, who manufacture machinery for plastics recycling. Some of the challenges that Technofa faced included the need to accelerate the development of, again, very custom machinery, and also being able to simulate critical components to minimize failures in the machinery that they manufacture. Some of their keys to success including using Solid Edge for assembly design with integrated finite element analysis capabilities to look at those critical components and minimize the amount of failures, but also making fast design changes to meet specific customer needs. Some of the results that they have achieved include decreased lead time for product development, optimizing components using virtual simulation. This minimized the amount of physical prototyping that they needed to do, which adds cost and time to their product development process, reducing material costs, testing and design time, and in general enabling them to provide continuous innovation for their design for recycling machinery. And the final case study I want to look at is this company Thermaplan that we looked at earlier. Thermaplan is based in Switzerland and they manufacture commercial coffee machines. Some of the challenges that Thermaplan faced, including packaging complex mechanical and electrical components in a small footprint, and generally time to market pressures to bring new designs to market. For them, some of their keys to success included the using Solid Edge for design of assemblies with up to 3,000 parts, and modularization and standardization of these designs using the built-in data management capabilities that come as a standard part of the Solid Edge software. Some of the results that they've been able to achieve include the management of large assemblies with up to 3,000 parts, easy modularization of these assemblies using integrated data management, and also photorealistic visualization of their designs for customer presentations. Okay, so just before we move on to the Q&A section, I'd just like to show you a slide which presents the complete Solid Edge portfolio. So you can see that Solid Edge is not just focused on the area of mechanical design, which we show in the left-hand column here. We actually have 7 pillars of capabilities in additional areas, including electrical design, which we've talked about quite a bit today, but other areas also including simulation, manufacturing, technical publications, data management, and cloud collaboration as well. So I think you can see how it enables you as a manufacturer to create a digital twin of your product and use it and add data and intelligence to it throughout the product development process. Also, a couple of next steps that you might want to consider. Certainly you can visit our webpage. The one focused on the Solid Edge product area is solidedge.siemens.com. There is an industries area on this webpage, and as today we're focused on the industrial machinery area, you could go to the focus webpage which talks more about applying Solid Edge to the industrial machinery sector. And also from here, you can access a free trial of Solid Edge software. So you can download the software and use it free for a period of 30 days.
This officially concludes today's webinar. Thank you for joining us and have a great day.